Hey there, my gorgeous friends on the internet. Hope you're having a wonderful day today. Are you ready for some more LeetCode? Let's do it. In this episode, I'm gonna sprinkle in a little bit of everything when it comes to array. A bit of hash maps. We're gonna solve a bit of hash set challenges and introduce sliding windows as well. If you're unfamiliar what we've been doing on this channel, I've been essentially following the LeetCode IO roadmap, which is a fantastic resource to kind of learn all these different data structure concepts step by step without like jumping around too much, and then your brain goes full regarded and then you don't end up learning anything. So if there's one thing only I ask from you guys: drop a little like. It helps out the channel so much. I really appreciate it. And let's get going. Before we get into the challenges, I want to just do a quick update on the CSS challenges I've been building out. You guys give me a ton of good feedback, and I've done all those changes. So for once, as you can see, if you go and you want to do this challenge, you get this nice like split view mode here, and you get the editor here. Before this, you'd have to like scroll all the way down to go to the code editor and go back up to see kind of how you are building out the CSS for this, which was a bit inconvenient. But now you can do that, and you can do split view as well. So I can go here, for example, and I can style this up if I do a background of red, for example, like that. There you go, right? But the one thing I'm like super excited about is you might not want to do CSS, right? You might actually want to just do this in Tailwind. So now officially we have a Tailwind mode, so you can easily just go here and you can simply write Tailwind code. So I can go here and say BG blue 200 right there. And look at that, boom, it updates, really cool. And we're supporting light and dark mode as well. So all these components have dynamic colors, which is awesome. And then you can get that right here. So you see like all the different colors that are being used in this project. We also measure efficiency now. So you can, it's going to count like all the HTML and CSS characters together and see like which solution is a bit more efficient, and a couple of other bits. So highly recommend you can check this out for free. I'm not charging you anything for it. And we also have an autosave feature, as you can see. So now it's saved. So if I go and refresh this, you're not losing your progress. So check it out. I'll leave a link in the description down below. Let me know if you like it or not. And yeah, let's start our LeetCode challenge. All right, let's get started. So just so you know, 9 out of 10 times when you're encountering array problems and string problems, usually it's a hash map, hash set, or some sort of sliding window algorithm. So let's look at the first one here, which is the first unique character in a string. So you're given a string, and then you essentially need to find the first non-repeating character and return its index. If it doesn't exist, just return -1. So LeetCode here, right? There's LEETCODE, right? So the output should be 0 because L here does not repeat anywhere else, right? L is a unique character, and then there's no other L's in here. In this example here, love LeetCode, the output is 2. So if we look at the index, so 0, 1, 2, so V here, right? V doesn't repeat anywhere else. Okay, so how can we do this? Let's have a look. Should we do Excalidraw? Let's do Excalidraw. Cool. Okay, so with a hash map, what we can do is we can check each individual character. So we can check L and then save the L as a key. And then the value, we can save it as a number. So we can say, okay, well, we encountered this one first. So imagine we're looping through this. We encounter L, we'll set that to 1. Next up, we'll go to E. So we get E, and then we just add 1 to this. But then when we go to the next character, we check if E exists in this hash map. And if it does, we just increment the value. So we add another 1. So we know that this is 2. And then we keep doing this over and over again till we reach all the individual characters through the whole string. And once we do that, we can just basically check, hey, which one occurred that has a value of 1, right? Because if it has 1, then it's a unique character. It clearly, we didn't increment it, so it only happened once. So that's essentially what we're gonna do. So let's give this a go. Okay, so let's get started. So the first thing we are gonna do is we are gonna create a frequency with a new map function. There we go. We're just going to initialize this. And now to basically go through each individual character, we need to do a loop, right? So let's do for let I, set that to 0. And I should be smaller, essentially the length of this string that's going to get passed in. So s length. And then we simply increment that. Cool. So here, if you want to see each individual character, you can essentially do s of I, like that. Let's hit save. And let's just run this quickly here. And there we go. We got our, let's clear this out. It doesn't run because we need to actually invoke this. Let's do first unique character, and I'll pass in the LeetCode. There we go. And if we run, as you can see, we get each individual character. You could save this if you want. You can do const character equals s of I, but we'll just keep it nice and clean. Okay, so what we'll do is now we'll start putting stuff into this map, right? So I'll do a check first if we have a character in there already or not. So if the frequency has the we'll do, which is it, the SI, right? That's the key, that's the character in this here. So if it has that character in there, then we want to increment it. Otherwise, we just want to add 1. So let's just handle the else statement first. So we can do frequency set, and I want to set the SI character, and I just want to add 1 to it. So let's just visualize this before we do the update. So if I console log out the map, which is our frequency, run this, there we go. So we added 1 to each individual character. But as you can see, E here should have 2, not 1. So that's where we handle the if case here. So we'll do frequency set, and then we'll just get the character that already exists in there. So nums I, and the value I want to set is whatever value is in there, and then add 1 to it. So we can do frequency get, and I can do nums, sorry, not nums, si, and then here we need si as well. We don't have nums. There we go. So we get that, and then we just add 1 to it, +1. Cool. Let's give this a go. And there we go, LeetCode, right? We have 3 in LeetCode. So it works. Awesome. Now what we want to do is essentially return this as soon as it encounters a unique character, right? So in this case, L would be the first character that it should encounter. So we can just loop over this again and just early return as soon as it encounters one that has the value of 1. So super simple. We can go down here. We can just do a for let I 0. I is smaller than s length, I++. And then we simply do if the frequency get, and then we'll get the s of I here. If that triple equals to 1, let's just return here because we found a unique value already. So return, and then here, remember, we need to return the index of this. So we can simply say return I. Cool. Else, at the end here, we can simply return -1 otherwise. This is the index anyway, so we can just simply return I. Okay, that should be it. So let's copy this over and see if it works. And look at that, there we go, that's pretty good. It's not the best one, but I feel like it's the easiest one to understand and to kind of wrap your head around it, and I sometimes value that more than a faster solution. Let's look at the next one, which is intersection of 2 arrays. So given 2 integers nums1 and nums2, return an array of their intersection. Each element in the result must be unique and may return the result in any order. So when you hear the word unique, that should ring a ding-dong, bing-bong in your head that this can easily be solved with a set, because sets can only hold unique numbers. So if your input here, for example, is 1, 2, 2, 1, and nums2 is 2, 2, the number 2 here occurs in both arrays, so we can return 2. In this case, we have 495, 94984, so we return 94. Okay, so we don't care that this 9 occurs here twice, we just care that it occurs in both arrays. Okay, so let's give this a go. So let's go back here. Okay, cool, there we go. Okay, so here's how we're gonna do this. First of all, I'm just gonna do 2 sets here, because when you create two sets, and if we add both of these arrays to each individual set, what's that going to do automatically for us? It's going to get rid of the duplicate values, and I can show you this. So I can say S1 for set 1. I'll create a new set, and I'll just plug in the nums1, right? That's our first array here that gets passed down. And then for S2, we're going to say new set nums2. So I just go here and console log both of these out. S1 comma S2. Let's see what we get. Look at that. So it pretty much filters out all the duplicate values. So this is super duper simple now because we can just run a loop, right? And then we can do a check, and then we can just return those values that occur. So maybe we can do a intersect array here. Intersect. I'll just set that equal to nothing. Empty array. Okay, so now what we can do is just grab one of these sets, whichever we want. Let's do S1, for example. Let's loop over it. We can do for each here on sets and maps. That works just fine. I'll get the number here, right? That's the value. And I'll simply check if S2 has it. So S2 has the number. If it has, then it intersects. So I can grab the intersect and just push in the value. You're done. That's it. Donezo. How simple is that? And then at the end, let's just return intersect. There we go. We can even do a little console log out to make sure this is all correct. So let's console log out the intersect at the end here. Let's run this. And look at that. We got 4 and 9 because all of these occur in each set. And there we go. Running this, as you can see, since we only have one loop here, where it's essentially O of n time, both cases passed and it performed pretty darn well. Awesome. Before I show you the sliding window problem, I want to solve another frequency problem that's a bit more interesting. It's not just about like counting up and adding to your map and then returning the highest number in the map or returning 1. I want to show you different ways you can approach and solve these problems. So you have Ransom Note here. Given two strings, Ransom Note and magazine, return true if Ransom Note can be constructed using the letters from magazine. So Ransom Note here is A, magazine is B. So you kind of remake Ransom Note here because you cannot remake something from B to turn it into A. Same here, you have AA, AB, right? I cannot remake AA because I need another A in here. Here, however, right, we have AA and AAB, so I can take these two to reconstruct Ransom Note. Okay, so let's copy this over. Let's grab all of this and replace it, can construct, and let's paste in one of the examples. So I'm going to call this AA, and then we'll do AAB. All right, so we can still do our frequency. So I can do const frequency is equal to a new map. Let's create our first loop. Let I, we'll set that equal to 0. I is smaller than, let's just loop over magazine for now. So just get one of these strings. Now again, let's just push in these characters inside the frequency. We can actually do this in one line. Before that, we did an if statement, but we can actually do it this way. We can say frequency set, and I'll get the magazine I, all right, so that's the character. And then what I can do here, at parentheses, frequencies get, I can check the magazine I if it exists there. Otherwise, I can add an OR symbol here to essentially put it to 0 if not. And then I just add 1 to it if it does exist. All right, so this is gonna solve itself. So if it doesn't exist, it's just gonna set it to 0 and then add 1 to it. If it exists, it's gonna return this case here. So if it's 2, and then it's just gonna add 2 plus 1 equals 3. So if we console log this out, let's just do frequency. Run this again. As you can see, we have 2 A's and 1 B's. So one way we can also do this is to essentially decrement now with the other one. So we can check in the ransom node, we can loop over that, and we're going to encounter A, and then we can just use this frequency to do a -1, and then we can do -1 again. And now we use the for loop up there, but we can even do a for of for both of these. So let's do one of these as well. For const character of ransom note, so we'll basically loop over the other one now, and let's get the count here. So let's say let count is equal to, I'll do a frequency get, and I'll get the character here. Otherwise, we can also initialize this with 0 if it doesn't exist. So if I just console log out count here, we are going to get 2, right? And what we can simply do is check if that count is bigger than 0. That means we can keep decrementing it. So we can say frequency set, and we can get the character, and we can simply say count minus 1, like that. Otherwise, we are out of characters, so we can just return false here. And of course, at the end, if this is true, then we can simply return true. There we go. So let's run this and see what we get. And there we go. Look at that. Awesome. Let's look at the final one that's going to give us a good introduction on how to do sliding windows. So this is the best time to buy and sell a stock. So you are given an array of prices where prices I is the price of the given stock. So the index dictates what price of the current stock we are on. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in which to sell. But it must be in the future, right? You cannot sell something in the past. That would be great. Return the maximum profit you can achieve from this transaction, or otherwise return 0. So you are given prices here. So it was 7 on, let's say, Monday, 1 on Tuesday, 5, 3, 6, 4, right? So the output here is 5, so day 5. So 1, 2, 3, 4, 5. So that would give you the best day of profit. Why? If you buy on day 2, that's the lowest, right? So 1 minus 6 is going to give you the best profit of 5, right? That's the maximum you can do. For this example here, the max profit that you can get is 0, because any day you buy, basically it goes down. It's a bear market, right? It's no bueno. Okay, so let's have a look at this. Okay, for this last problem, I feel like if I draw it out visually, it's gonna make a little bit more sense. So let's see here. What we're gonna do is we are essentially gonna set a variable here called left. And this will represent when is like the best time for us to buy. So I'll put this to 0 for now, which is gonna indicate the index. Let me just put best time to buy. Okay, buy. So here, we're gonna try first day to buy this. Okay, so that's kind of what a pointer is. We're just pointing to a specific spot in our array here, to a specific index. And then when we want to sell, let me put sell here, which can be our right, you can also say. I'm going to set that equal to 1, which is going to point to the next day, right? There's no point of putting it here, because if we buy and sell in the same day here, in this case, it's just going to be 7. So we're not really going to get any like max profit or anything. Okay, so you essentially do a check here by comparing these two pointers. So you're going to look at the numbers in there and see, okay, well, is 1 bigger than 7? It's not, right? So clearly there's a cheaper time to buy. So if there's a cheaper time to buy, what we can simply do is set this left equal to the right now, because that is cheaper. So we can take this, and in that condition, we can simply move the pointer over. And then the cell here, this is like a loop. You can just imagine we're going to hop over through each of these numbers and do a check. Okay, so now we go to the next number. Okay, so 5. So is 5 bigger than 1? In this case, it is. So now in this conditional, if it's bigger, we can simply calculate the max profit. So we can, maybe we have a variable here called max profit, which is now, if you do 5 minus 1, that's our new max profit there, 4. Okay, let's continue. This is still our cheapest time to buy, because we haven't encountered a conditional where 1 is essentially bigger than, you know, like 3, right? Okay, so now we simply move this over to the next one. So we are gonna go over to 3. So we're gonna do the same check. Is 3 bigger than 1? It is. But if we do 3 minus 1, it's only 2. So our max profit doesn't increase. So then we move over to the next day. So we're just moving these pointers around to get the result we want. So next one, we got 6. So 6 minus 1. Oh, That's bigger than the current max profit. So we can have a check there to check the max profit. It's bigger, it's 5. So if you do 6 minus 1, you get 5, which is our new max profit. And then finally, you can move over to the last day where you have 4, and then you can do the comparison again. It's going to be 4 minus 1, which is 3. So our final max profit is going to be 5. Okay, so let's see how this is going to be coded out. So like I said, we have the right position and the left position. So let's do the left one first. This is going to be our buy date, right? We set that to 0. And then we have the right position, which we set to 1. This is the thing that it's going to like loop over each individual number. So that's the sell date. Let's also add a max profit here, which we're just going to initialize with 0. Okay, so we can create that condition with a while loop. We can just say if the right is smaller than the prices the length. Again, we're just using right here to loop over everything. There we go. We can do a console log here. We can just say prices right, for example. There we go. Now this is going to create an infinite loop. If I run this, sorry, I need to console log this out. Console log out prices right. Okay, run this. See, it just keeps going and going, infinite loop, because this condition always stays true. So let's just say right plus plus in here at the end. Okay, cool. So now if we run this, why did that change it to const? I didn't want that to be const. Keep it let. Why does it? That's really weird, eh? Okay, there we go. So now it breaks out of it. Cool. And now we can do a simple check here. We can check if the sell day is bigger than the buy day. So if the prices sell day right is bigger than the prices left, which is our buy day, that means that we're getting a profit here. Otherwise, else here, we can update the pointer like we did here, right? When we had the buy day at 7, and we had this here, we checked if 1 was bigger than 7, and it wasn't, we just updated the left to the right. So we just took this and moved it to the right. So that's what we're doing. We're just say left equals right. Easy as that. Otherwise here, it means that we actually have a profit. So I can create a profit here. And essentially I want to do prices right. So we're taking the sell day and saying minus whatever our buy day was. So left. There we go. And we can simply get the max profit and update that. So that's simply going to be math.max, and we can simply pass the max profit down and profit here like that. So what does this do? Well, it's only gonna, you pass 2 parameters down, and it's only gonna return the one with the highest number. So max profit is 0 here initially, and then profit here is gonna be, well, it's gonna be, what is it gonna be? It's gonna be, well, in the first loop, we're just updating the buy price, so the left to 1, and then when we're checking the next position here, it's going to be 5. So it's going to be 5 minus 1 here. That's what we're going to do here, which is going to be 4. So it's going to be 0 here and 4 here. So the new max profit is going to be 4. And then on the next check and next check here, when we get to 6, it's essentially going to compare 4, right? That's the current value here, versus 6 minus 1, which is 5. So it's going to be 4 here and then 5 here. So it's going to return the higher number. So it's going to be 5. And that's how we get the max profit. So there we go. That's pretty much all there is to it. So let's see how this does. Let's copy it over. Paste it in and run this. And we get an error because we never returned the max profit. So let's simply return that here at the end. And hopefully, let's do it. Come on. Yes, there we go. Beat. Awesome job. Wasn't the fastest solution here, but that's all right. I'm going to actually have a look to see how people have done it here. 0 MS. What the hell? You have a quantum computer. That's crazy. Anyway, that's it for me. Hope you enjoyed this little episode. In the next one, we're going to explore a bit more fun stuff with pointers. It's going to be a good one. Drop a like, drop a subscribe, and I'll catch you in the next one.